Okay, so welcome back. Now we're going to do a couple of examples involving integration. So now in this problem here, we have a function, natural log of 1 plus x. And what they're asking us to do is for this function is find a power series representation for f, okay, by using f prime of x. And then find its interval of convergence. So what it means is what we're going to do is we're going to kind of go in a circle. So this is kind of neat. So what we're going to do is to find a power series representation of this, we're going to differentiate this function, right? So we know f prime of x. Now here's the thing. F prime of x is what? The derivative of this divided by the argument, 1 plus x. So the derivative is going to be the derivative of the inside function times the derivative of the outside function, which is 1 over the argument, okay? So the derivative of the inside is just 1. The derivative of the outside function is du over u, which u is the argument, right? So the derivative of the inside, again, is 1. So it's going to be 1 over 1 plus x. Now, this is equal to 1 over 1 minus negative x. And so now we know that this is equal to the power series representation of n equals 0 to infinity of negative x to the nth power. Okay, good. Now, what is this equal to? Well, f prime of x is equal to what? It's going to be 1 minus x plus x squared minus x cubed, and so on. Okay, so now, here's the thing. We know that this is true on this interval, right? So we know that this is true for the absolute value of x is greater than 1. Okay? So we know that's true. Okay? So now, how about that? So now, to find the power series of f of x, right? So now, this is what we want a power series for. So, but we know the power series for this, and we know this is equal to this, which is equal to this. So to find f of x, right, because we know, right, we can differentiate this term by term. So if we differentiate this term by term, guess what? We find that f of x equals what? C plus what? This is going to become x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4. And so on, right? Now, at this point, since we know that f of x equals this, right? And that's the antiderivative of this, right? And so all that's left is to figure out what c is. And obviously the easiest way to find out what c is to make x 0, because if x is 0, all of the other terms go away. And so we know f of x is equal to this. So if we plug in 0 here, we get natural log of 1, which means 0, which means This is 0. All of these are zeros, and so we end up with c is equal to 0. And so our final answer then becomes f of x is equal to this. X minus x squared over 2 plus x cubed over 3 plus, minus x to the 4th over 4 plus, and so on. Okay, so now, what does this give us, though? Well, first of all, we've got our alternating series, okay? We've got an alternating series that starts at x, positive, okay? So if we're going to write this, let's write it as, n equals 0 to infinity, okay? So the first thing we need is we need -1. And if we put n, well, if n is 0, this is just going to become 1. Okay? Now, let's see here. So if we want to write this another way, let's write this as x over 1, right? And so if we write this as n plus 1, and then this would be x to the n plus 1, right? Okay, so that would work. But, it's not exactly in the form that we want it in. Let me think here, So if x is 0, so that'll give us that, and then if x is 1, okay. Now if x is 0, if this is 1, we get a minus, right? If x is 2, we get a plus, and this is going to be x to the 3rd over 3. Okay, so that works, right? But we want it as a power series, so we don't want x. We don't want the n plus 1. We want x to the n. Okay. So here's what we're going to do. We're going to subtract 1 from these. We're going to add 1 here. And then instead of starting at 0, we'll start at 1. So if we start the series at 1, we get the same thing. We get, this is going to be 1, so this will be 2. So we get positive 1. So that'll give us positive over here. And then we get x to the 1 over 1. So we get this, so that'll give us this term. If we do n equals 2, we'll get -1, so that'll give us a negative sign, and then we'll get x squared over 2, and that way we'll get the same series. And so this is the final result. Okay, now, and of course the interval of convergence for this is -1 to 1, or we say the absolute value of x is less than 1. So that's true for all x, all absolute values of x less than 1. Okay, now we still have to test the endpoints. Okay? So now, because all it says is what's in this interval, but it doesn't say what as far as the endpoints go. So again, if we plug in -1 in for x, we get the harmonic series. No, I'm sorry. If we plug in -1, we get the alternating series. Okay? The alternating harmonic series. And that converges, as we know. Hold on a second. Hold on. Let me double check. Hold on. So if this is -1, I get -1 to the n plus 1 plus. Oh, okay. Hold on. So I'll get if x is -1, I'll get -1. So I'll combine these. I'll get -1 to the 2n plus 1, which will be odd. So if n is 0, I get 1. If n is, hold on, 2n plus 1. Okay, 2n. And if n is if this is +1, then that's just going to be 1, and I'm going to get a harmonic, the alternating harmonic series, which is converges. So converges when x is 1, and when x is -1, you get the harmonic series. Yes. Yep. So because this will be 2, so this will always be odd, so you're always going to have a negative number, but you can pull the negative out, and so you get the harmonic series. So it's going to diverge at -1, but it's going to converge at +1, so the radius, or excuse me, the interval of convergence becomes that. And I believe that's all they wanted us to do. Okay, one last thing before I let you go is this. Just because we show that it converges at 1 does not guarantee that just because it converges at 1 does not guarantee that this series converges to this at x equals 1. For example, just because it converges at 1 doesn't mean that it's going to actually converge to natural log of 2. In fact, this doesn't. I'm not going to show you that because it's beyond the scope of this class, but this actually does not converge to the natural log of 2. Okay? So be careful. Just because this is our interval of convergence, and it does converge at x equals 1, but it doesn't necessarily guarantee that it's going to converge to the value of the function at x equals 1. Okay? Hope that makes sense to you. Okay? There's a theorem called Abel's theorem, if you want to look it up, that's used for this. Okay? Or for that, I should say. Other than that, have a great day.